Hey, what's up, Ziguanas? This is day 17 of the 30 days of Z Coding Challenge. Join me as I apply over 2 decades of professional programming experience and around 15 years of code teaching experience to master a new language. The name of the language is Zig. My name is Dusan. Welcome to Zignited. So day 17, I'm going to continue the topic that I started yesterday, which are coercions. I stopped somewhere here. Yeah. So the next part is coercion of the optionals. So I'm basically halfway through. But yeah, yesterday actually I started with optionals and then went with casting. So hopefully I will finish optionals, not optionals, sorry, casting and coercion today. So let's see the next part here about coercion with optionals. The payload type of optionals as well as null coerce to the optional type. Okay, so let's just play a little bit. And this was the code from the TikTok. So let's do this part here. And let's see what they do. Yeah, before I continue, just for the ones that are maybe watching this series for the first time, 30 Days of Coding Challenge Zig. So basically the idea is that I learn live in live stream. So I didn't know Zig. I haven't seen a single line of code like 17 days ago. So that's the idea, that I document the process of learning. So not a tutorial, just documenting my process of learning, but still I will create a tutorial after I finish this 30 days of coding challenge, and I will start publishing videos that are tutorial. So I will explain what I learned when I dig deeper into Zig. Okay, so let's see what they're doing here. They make a constant x, which is an optional type, i32, and they assign it 1, 2, 3, 4 to it. And here they do the same, but they assign a null. So basically optional type can receive either this type that is optional or null. So that's okay. And then they expect here, so I will print like before. I will not use try here, just to see things, because I think it's more interesting to do that. So let's say x equals this, and then do the x here, and I will do the same for y. And let me go to the next line as well. And let's see, this is what they expect. Let's see when we run. I mean, it's pretty straightforward, but let's just see. So basically the point here that they are casting, oh, what is their, okay, unused local constant, because I just printed copy pasting, I printed x only. What they say? Where is the board? Ah, sorry, this is main. Again, copy paste problem. So main, and it should return void. So nothing. What does it say? Now it's, okay. So for the null, let's do any for 1, 2, 3. I don't need to. 3, 4. What does it say? Wait, this is weird. What did I do? Let's try any here as well. Okay. Yeah, because it's optional. I forgot the type is not integer, although it looks like integer, but it's optional. Yeah, so this is the part that is in focus here today. So having a literal that is comp time integer in this case, and then casting it into the optional type, which is optional of i32. And here the same. So they're casting the null literal to the same type, optional i32. That's the point here. I have two of these. Okay. So this is coercion, basically, of these literals to optional type. And like I said, this is comp time int, and this is null. Okay, let's see the next one. Optionals work nested inside error union type 2. Okay, let's see them. I will just comment out. I don't want it. Maybe I will need it for reference. And then this part I will delete. And this part I will comment. So let's see what they did. Yeah, by the way, I did not mention things from yesterday. It's here. So looking in the wrong page. So here, this is interesting part as well. So x dot question mark basically unwraps the optional into the thing that is inside. In this case, 1, 2, 3, 4. Let's see now the next example. So this one, where they said optionals were nested inside error union type 2. Let's see what they do. So another x and y constant. And they have, oh, this is so interesting. So this is, first I think it works from right to left, should be. So it should be, first of all, optional of i32, and then that optional is in a union with any error. So because they use these two operators, one for the optional and one for the union. Let me just think. Options were nested inside error union type. Yeah, because they say it's error union type. It is what I just said. So this union is uniting this and this. And this happens first. So first the optional is, let's say, formed, and then the union with optional and the error. Okay. So in this case, they assign again this to the optional. So this happens first. So it becomes optional 532, and then there is a union with error. And here as well, just like different literal. And let's see and run it. Yeah, I want to do this actually now. This is different. Oh, okay, this is also interesting. How they try and then unwrap it, and they then try to compare it with 1, 2, 3, 4. Just try to play with. If I do this here, so this is, then it's not going to be x, but doesn't matter. If I instead do this, just to see, and I can do also the same for try, and see what I'm going to get. It will be an error, or yeah, it works. Okay, this is nice how they nest tries. And let's see the next thing. Type coercion error unions, and here we had error union type. Okay. Okay, they directly have a union between the type and the error, not with the optional. Okay. Let's see what they say. The payload type of an error union type as well as the error set type coerce to the error union type. Okay. So basically this is just error union type, and here they are saying also works with the error set type. Okay, so let's do that. I will do it here. then let's see this part here, comment out, and this part delete, and this part just comment out for the reference. And now let's see what they try, the same thing, so I will just leave it X in this case, not this what they have, and then in this case, let's see this part. Oh no, I cannot because, okay, let's try Y. And how it will work. Okay, yeah, so it is what they expect. Error failure is equal to Y. So yeah, basically they create a union here of the type and the error, and in this case I believe this is the set, right? So they cast it, coerce it to this union type. Okay, let's see the next one. Type coercion, compile time known numbers. When a number is comp time known to be representable in the destination type, it may be coerced. And let's see what they do. Again, let's comment out these I will delete, and here paste the next thing. Let's see what they do. They have 255, a literal, which is contained. They then coerce it to U64, and it is possible because it's a constant thing. Okay, so that's why they say compile time known numbers. Okay. So yeah, this is known as a compile time because it's a constant, and they coerce it to the constant U64. Okay, and here they use, this is also now known as a compile time because it's a constant, and they just coerce it to a lower size, and it is possible, so this is probably the most interesting part, because they're trying to coerce the larger type, much larger type, into the smallest unsigned integer, like 8 times smaller, but they can guarantee it's going to be safe because this is a constant, so a compiler will check and it will see if it can fit in this type, and that's why it works. That's nice. And let's see here, if we just print both, they should be both 255. Yep. Okay. The next thing, type coercion, unions and enums. Sorry. Tagged unions can be coerced to enums. Yeah, I remember tagged, so when they define a type, right? And enums can be coerced to tagged unions. It works both ways. When they are comp time known to be a field of the union that has only one possible value, such as void. Okay, this is very restrictive and a long sentence, but let's see the example. Okay, first of all, they define them here, and then this is where they test. So let's do something similar. I'll define all this here outside of the main function, and let's see first of all if their code runs. For example, is invalid. Okay, nevertheless, I will copy it to see how it works. Let's say here in the the main function. So now I will delete the previous things because this is too large. And let's see. Let's print these things one by one. So first they expect E to be E.2. So I will comment this out and just print E instead. Here. The next thing, the U2, similar things. So comment here and the U2 here. Then u3 and u4, the same thing. Okay. So let's first see if this runs. Not, I will have to maybe paste the structure into the main. I didn't pay attention what's inside, but sometimes it's necessary, and in this case it's not. Okay, perfect. Let's see, first e2, and that's what they, oops, here, what they expected. Then 3 equals void, 3 equals void. So 3, 3. So they say it's 3, but they display it in a different way. I will check on that first. I want to see here what they are doing, and then u4 equals to this case 1, and in our case void. So let's double check what's happening here and why. And is it actually, yeah, it's the working part. Because I thought maybe this part that they said it will not work, but it's not. This part should do what they say. So, okay, okay, my mistake. So they are looking into the u4 tag, not u4. So here it's u3, that's okay to be void. But for this example, it's not u4, it's u4 tag. So let's do u4 tag. Yeah, it's 1. Okay, now let's examine what actually they did. So first example. So actually I will take a look here because it's easier. It's not so zoomed in, so I don't want to scroll for you guys so that you can see everything at once as well. So first things first, they create a u constant and then e, and they use the u to cast it into the e, and e is this type. And the initial u is of this type. So basically these two highlighted parts are the only things that matter for the first example. So first of all, let's see, they create a constant of u, and now I will show it here to be more visible. So a constant of u is union, and this is the tag e. So it is basically about this type. So let's then check this out first. So this is e, which is an enum, which has these 3 fields, 1, 2, 3, named like that. And then here they create a union where of this with this tag e, and they also have 3 fields. One of them is I32, one of them is F32, and one of them is void. Right? So then let's see what they do here. So they create the union u, and they activate this field 2 with this value 12.34, and that is okay because this is a float 34 of 32, so it can receive this number, and then they coerce it to the type e here, which is the enum, right? And then they just name the constant lowercase e, and then when they expect here, so or when I print, it is e2. Why it is? Because it was here 2, so in the union it was the field that was activated as with the field 2, right? And then here, because they coerced it, now it's enum with the field 2 selected, and that's why here it shows e2. So in the print it says e2. Okay. Then the next example, what they do there. So e and u. So they use the same union and enum. So let's just scroll then, because now we're familiar with the union and the enum. So they first of all, right, so this is kind of like the opposite now. Here they created a union and then coerced it to an enum. Now they are doing the opposite. So they create a constant 3, which is enum 3. Then they want to change that, coerce it into the union, and they call it u2. And the union has this thing here, which is 3, which is, like you can see here, void. So that's why when I print down there u2, we get void. Makes sense. Okay, then let's see the next thing with u3. They say u3 is a constant, which is of the type of the union u, and they select dot 3. They activate dot 3, which is a void again. So yeah, basically that's why this is u3. So in this case, they were cursing the enum into the union. In this case, this is the field that is inside of the, that is activated here. So enum literal, how they say call it. I was about to say that I don't know exactly how they formally call this, but it's called enum literal. Okay. I thought they are going to say like something like enum field or something like that, but this is maybe, not maybe, but of course, if they're calling it enum literal, it's probably the most precise definition of what it is. And let's see the last example in this part. So they are using dot a, and I forgot where there is an a. This is u2. Okay, I have to be careful. So this is now, yeah, u2. So it's a different one. That's why I was unfamiliar with a, because I kind of memorized these 3, 1, 2, 3, and that's why I didn't see this one, because it's a different union, and this is a tagged one. So here they tag it to enum. They have these 2 fields. The first one is explicitly void. The second one is f32, float32, and they have a function inside as well, which is called tag, which has one parameter, which is a self. So the instance of usize itself will be running under the hood when you call the function. Then the return value of the function is usize, so unsized integer, depending on the architecture. And then they have switch inside of the function. Okay, so they take this instance of the union and switch it. And then they say if it is .a, this function will return 1. Otherwise, the function will return b. So basically, if this one is activated, the function returns 1. And if this one is activated, the function returns b. And now, back to their test. So they are making this constant called u3 of this, sorry, this one, where we went through this one as already. So here they are making a constant called u4, which is of type u2, which we just examined, and they activate the field a. So they are coercing this literal, enum literal, to a union. And how they say with inferred enum tag type. Yeah, so this is going to know it's going to be a enum type, and then we get 1. When I print what I print down there, u4.tag. Okay, that's why. Because it's inferred that it's an enum type. So let's go back to the definition. So this is, sorry, this here, it's an enum. So we activate a1, which is void, right? But then they want to basically call this tag function here. So they call it here when they expect, but I call it here explicitly outside of the try expect, just like inside of this formatter. So I'm basically having here u4, which has the first field .a activated, which is void, with the value void, but then I call the function tag. So basically what happens is I call this function, which receives the instance of u2, which has the activated field of a, and then it's switched, and because it's in case of a should return 1, that's why in this case we get the 1. Okay, that makes sense. Let's go to the next example and let's see what they say here. By the way, why this is invalid. Coercion from enum, type of enum literal to union test coerce enum u2 must initialize f32 field b. They have ru5, they set it to b, then they call to tag, and then it's not 2. And let's see why. Type of enum literal to union test coerce unit must initialize f3 field b. I don't quite understand the comment here, but I will not spend now too much time figuring it out. I want to move forward. Let's see the next topic, type coercion undefined. Undefined can be coerced to any type. Okay, so they literally just say that, and they move on to the coercion of tuples and arrays. And this is the last thing before explicit casts. So because I haven't touched tuples, let me think, should I now go deeper? Well, let's see how wide are explicit casts, because there are like literally 2 items left to finish the casting, except for this coercion tuples to arrays, and I just want to see what is shorted so that I do it first. Type resolution, yeah, this is not short at all. And then 0-bit types, I've done that before when I played with null. So let's just see first of all explicit casts. Explicit casts are performed via built-in functions. Yeah, I did some of them before. I needed them for some other chapters. Some explicit casts are safe, some are not. Some explicit casts perform language level assertions, sorry. Some do not. Some explicit casts are no ops at runtime, some are not. Okay, so 3 cases of maybe. Okay, let's just quickly go through them. Bitcast, change type of chain type, but maintain bit representation. Okay. So zeros and ones are the same, just different type. You treat it as a different type. Okay. Make a pointer, have more alignment, align cast. Enum from integer, obtain an enum value based on integer's tag value. Error from int, obtaining error code. Yeah, this is useful. From integer based on its integer value. Error cast, convert to a smaller error set. Okay, to subset. So I remember from error chapter that it's not possible to do the opposite. Float cast, convert a larger float to a smaller float. Aha, this is explicit. No, actually, this is not possible directly. Sorry, my mistake. So the other way around works implicitly, but here you have to cast it manually. Float cast, again, for the same reason. So because you're forcing the larger float to a smaller, it makes sense that you have to do that manually. Float from integer. Okay, because basically here you can lose some data if you go around, right? You can lose data if you coerce float to integer, but in this case you probably want to coerce to do it manually, just to force it if you have a literal or something that is string and you, sorry, integer, and you need it for some reason to be float. Okay, integer cast, convert between integer types, integer from bool. Okay, this is nice that you have to explicitly do it as well. Integer from enum. Okay, obtain the integer tag value of an enum or tag union. That's pretty clear. Integer from error. Obtain the integer value of an error code. Okay, so this is kind of like the opposite of this one. Integer from float. Obtain the integer part of the float value. Okay, round it up basically. One way to round it up. Integer from pointer. Obtain address of a pointer. Okay, pretty self-explanatory. Pointer from integer, the other way around. Opposite of this. Pointer cast, convert between pointer types. And truncate, finally, convert between integer types, chopping off bits. Okay, so this is pretty clear, all of these. Your type resolution. First in these places, switch expressions, if expressions, so they don't explicitly say anything, so I will just keep it. And this is the last thing. No, actually, these are all examples of pure type resolution, so I will definitely skip this now because it's a longer topic. I will go back to tuples, or tuples, however you pronounce them, and then I will come back here. Tuples. So anonymous structs can be created without specifying field names and are referred to as tuples. And an empty tuple looks like dot curly braces and can be seen in one of the Hello World examples. Yeah, so here. Yeah, so this is something that I used. I didn't know that they call them tuples. So in some other languages you will have different definitions of tuples. But here in Rust, I've noticed this before. In my previous live streams, you can see that. And I just call them anonymous structs. I didn't know that they are officially called tuples when they're anonymous. But it's a nice thing to know. The fields are implicitly named using numbers starting from 0. So this is also something that I experimented with, because you have something similar in different programming languages when you format strings. So they're not called tuples there, but the principles are the same. So when you put curly braces in a sequence on the string, you're basically doing string interpolation, and then when you have parameters that you inject there, the same principles apply. So they're like indexed based, and you can check when I played some of the previous videos when I played with these things, and I didn't even know that they are calling them tuples, but it's, like I said, very similar to logic in other languages. Their names are integers. Because their names are integers, they cannot be accessed with dot syntax. Okay, makes sense. Without also wrapping them in at. At and quotes. Names inside at quotes are always recognized as identifiers. That's why they use them. Okay. I was also thinking about this, why they are using the syntax. Like arrays, tuples have a .len field. Can be indexed. So for the index, I just like checked it and I figured out on my own, but I didn't know that they have length. Provided the index is comp time known. Okay. So we have this limitation, and work with the plus plus and star star operators. They can also be iterated over with inline for. Okay, so I remember the star star operator on arrays. So it's possible, I believe, to use it only on arrays, and then basically it multiplies the array. So it takes the elements, and if you say star star 2, it will do 2 times that. So you will repeat 2 times. Plus plus, I've never used it here myself in Zig, so it's not increment like in some languages, but I've seen it, so that's why I think I know what it could be, because when I made some mistakes, it said like the formatter is expecting one thing and you're not providing it, and so on. And then I remember seeing this in the error message, so it was saying something like plus plus, and then some pieces of the things that I wanted to inject into string. So that's why I think this is for concatenation. Maybe I even read it at the first lesson when I actually second video when I went through the operators, but I don't remember. Okay, Let's see what example they provide. So tuple const values, let's take this part and paste it here inside of the main. And I will just leave one of these prints, don't need all of them. And let's delete now this part above so that I can focus. Okay, const values equals, so this is a struct, right? This is not a tuple. Ah, no, it's a tuple because it's anonymous. Okay, okay. Got it. So this is a tuple. So then they apply this, they call this built-in function as. So basically they take the literal 1, 2, 3, 4, which is compile time integer, and then coerce it to U32 type. And here similar story, but they take the float, comp time float, 12.34 literal, and they coerce it to, or how they say, explicitly cast to F64 type. Then they have true, which is just literal, so they don't try to change the type, and then high, which is a string literal, which basically means, because there is no string type in Zig, it's an array of bytes under the hood. So this anonymous tuple has 4 different types. I guess that's what they wanted to show, that you can mix types. So they take it, and then they use this plus plus operator. I think this is like merging it, concatenating what is the appropriate expression when you speak about joining two tuples. So they join it with false, and then they apply this times 2. So I don't know about the precedence of the operators. So if they are the same precedence, then this will happen first, and then this. So basically, if I'm guessing right, we should see float, sorry, unsigned integer, so this one. So this one, this one, this one, this one, and this one. And again, the same thing. If this happens first, and then this happens later. Or I don't know, if this one has precedence, then it will be 2 times false after these 4 guys. So let's see which one has the precedence. And I will just comment out this part for now, because, and this one as well, because I want to see these values thingy, what it is. So values, I will say any, and print here. Okay, so it's the second thing that I mentioned. It's false, false at the end. So this one is the first element. So first of all, this one happens first, right? So first they will take this tuple, and then they will double it. So that's why you basically have curly braces, false, comma, false, curly braces, and a dot, let's say, if it's a tuple. And then they apply the plus plus, meaning like joining these 2 tuples. So this is the first one, and this is the second one. Now happens second, and they create this large tuple, which contains in this order 1, 2, 3, 4, which is unsigned integer 32 bits long. Then this one, which is 12.34, but they have this scientific notification. So basically 1.234 times 10 to the power of 1. So 10 to the power of 1 is 10. You just multiply 1.234 with 10, so 12.34 exactly. Then true from here. Then what I said, because there is no string type under the hood, it's creating an array of bytes. And this is the first character, H, so it's a ordinary number of H in the Unicode, which is 104. So if you guys want, we can Google up Unicode table, and you will see this is the ordinary number of H, and this is the ordinary number of I. So this is for the string, and then false 2 times. Okay, nice. Then let's see what they do here. They try to get the first thing of, so basically this is indexed tuple. So if you say square bracket 0, it will get the first element. That's why 1, 2, 3, 4. And 4 is the 5th element. So 0, 1, 2, this is 3, this entire thing. And then 4 is this one. That's why false. Then let's see this one. Just one comment. It's easier to follow if it's colorized. Inline 4. I haven't played with this inline, so I have to check what this one does. But let's just try to figure out what the 4 part does without this inline. So this inline obviously modifies this for loop somehow, but let me just try to figure out without it. So it says go through the values, this one, from the beginning until the end, I believe. So this is the capture group. It takes V and I. So I believe, so I haven't seen this. I mean, it's probably here in docs, but I haven't read the docs about this. But it kind of looks like some, for example, in Python, you have, if you iterate through dictionary and there is a method called items, you get basically the value and the key, which is something I guess this is like the value and the index that you get. So I don't know if this is automated like in Python or simply because you are using this range here, should be range, or I don't know what is exactly in this location, but it's either it's automated or it's generated because of this. So maybe this is more probable that it's generated because I said 0. If I said maybe 1, then maybe the first type will be actually 1. We'll have to test to be sure, but this is what I guess. And then this is kind of like the input, what you get in every iteration for the for loop, like in the body of the for. So then they ask if I is not equal to continue. And then they have try expect here v. So in my case, what I will do instead of try expect, I will just print here so that we have the same logic. And just want to print the v. So legend, hello legend, what are you programming? I'm just going through the documentation now. So I'm going through tuples and playing with them. So Zig documentation, tuples. I did code yesterday or 2 days ago. I did a practical. So how I concept this for now, this channel. So I have this 30 days of Zig coding challenge where I learn live in live stream. So I haven't touched Zig before, like 17 days ago. I had 0 Zig experience, and I'm learning live by streaming. And then after 10 days, I had something like overview of the things I've learned, and I practiced by creating some small tic-tac-toe game. And then five days later, which was 2 days ago, I refactored that code to use the things that I've learned. So meanwhile, I learned functions and pointers, and then I applied that 2 days ago. So that's the idea. Now I'm just playing with tuples. Okay, so here I will just print these guys, these v's, and let's see. So it should just keep, if it's not the second, the index 2, which means basically it should print only the third element here, which is true. Yeah, okay. So what I expected. I would immediately dive into some project, to be honest. Yeah, I literally have 0 Zig experience, so it would be extremely hard to try to do anything before I just go to the docs and to see what's there, what I can use. So I've never used Zig before. So literally 17 days in my life, I'm playing with Zig. That's why. But I'm very close to the end of the documentation. So this is day 17. So basically, I got through all of these things from the beginning. So all these, most of them at least, if maybe I skipped something that I'm not aware. And basically I'm here. I'm doing casting today, but because they are casting tuples and I did not play with tuples, I went a step back. And then if you check, it's literally like what you see on the screen is what's left of Zig in Zig documentation. So I will finish in, I don't know how many days, but before I think these 30 days expire, I should be done with all the documentation, and then I will do some more serious project. That's the idea. Yeah, so small programs are just to start with. So instead of just like watching a tutorial or something, like reading a book about Zig, I just like test the things immediately. Yeah, I'm hello. Say, sorry, I don't know how to pronounce your name. Sahedul Hek. Sajdul Hek. I'm following Zig documentation, yeah. Okay, so this part is clear now. Then let's see if the length is 6. Okay, so we can count 1, 2, 3, 4, 5, 6. Yeah, this will be 6. And then, this is interesting because I haven't used this syntax dot at before. So I'll take this and paste it here just to see the example. So this one. And run. Let's see what has happened. There is a comma missing. Where? Sorry. So, of course, I will just do this without quotes. I'm inside of the string. Didn't pay attention. So let's do this. Okay. So what I guess what they do, they take the values, use this syntax to get the element with index 3. So 0, 1, 2, 3. So they target this entire thing, and then they go inside. Because this is an array, the first thing inside 0 value is 0 index is 104. Okay, makes sense. Destructuring tuples. Let's see what they say. How do they destructure? Yeah, following documentation, like today and 13 more days, and then I'm going to do some larger project. Still don't know what I will figure it out. So it's basically 2 weeks from now. And in these 2 weeks, I will have, for sure, in 3 days, I will do one more code practice where I will play with some smaller things. And then probably at least one more time. So at least 2 more times I will have something like a smaller coding practice about like 1 hour and what I can do in 1 hour, maybe 2. And then I will do at the end, I will do something more complex. Do you have any projects in mind? Yes, I have a general idea what I like. So I like WebAssembly. So I would like to explore something related to WebAssembly. So I will figure it out. Still don't know. And yeah, that's about it. So still, I have a general idea what I would like to do. So something related to WebAssembly. Structuring tuples, okay, can be destructured. Is helpful for returning multiple values from a block. And let's see what they do here to test things and play. So let's see. First variable, they call it minimum, and then it's i8. It's the lowest possible i8 value. Then the max, the same thing. No, actually, why it's called max if it's minus? Probably they're going to search for the maximum value or of something. So they are kind of like setting the default value, which is the farthest away from the actual. Okay, then for loop, 4 digits. And then they take the digit, this capture group, and then they take and test it. If it's lower than minimum, where these digits come from? Here. Sorry, I missed it. So it's an array of i8s of dynamic size basically, but we can see that there are 7 numbers inside of them. Okay, so they loop through these guys. Then they ask if the digit, the current one, is lesser than minimum, then they set the new minimum to that digit. So pretty straightforward, simple algorithm to determine what is the minimum, what is the maximum value of these guys, these numbers. Then they break the block. So I didn't even see. Aha, here is the label of the block. Okay. Aha, so this is in the block. I missed that. So this is where they want to assign minimum and maximum with the comma notation. Aha, this is the structure. Okay, that's what they want to say, because they are returning here the anonymous structure, which is a tuple, and they put these 2 elements inside. So first minimum, then maximum. So basically this code block will get you a tuple, and they destructure it here by taking these 2 elements separately into these 2 variables. And it's interesting that you have to repeat this const here. So you cannot just say const min comma max. Okay. Then they print both of them. So okay, that's pretty straightforward. We can run and it should work fine. It should be like 0 the minimum, 9 the maximum, right? Let's see. Yeah, 0 minimum, 9 is maximum, but I will just add these things for the sake of readability. Okay, cool. The next thing, I went through this. So this is basically the end of the tuples, right? So I can then go back to where it was. Yeah, here. I just didn't click it. So tuples can be coerced. Wait, did I go back to the... Ah, no, I skipped this part. Structure is helpful for dealing with functions and built-ins that return multiple values as a tuple. And then they do enums. So this is actually the last thing for tuples. Let's see what they do. So I will copy paste these things because it's larger. My editor here. So let's do it like this. Delete the previous prints, and then I will take the function outside. So now I don't need this part. That's okay. I don't need these digits. I just need here this function, and that's about it. And let's see what they do. So they call div mod. So I can guess then what they will do. Numerator u32, denominator u32. Those are the inputs. It returns the struct, which is containing 2 elements u32s. Then they immediately return 2 things. So first they divide numerator by denominator. So that's the result of the division. And then they do the numerator modulus denominator. So that's why the modulus. And then they just call this function, which returns this tuple, where these values 10 and 3. And they assigned the division result to the div constant and the modulus result to the mod constant, and they just print it. So it should be 3 and 1, right? The result, yeah. And I haven't even tried, or I don't remember that I tried this division. So it's an integer division by default if you have numerator, denominator, which are integers. Okay. If I read it, I forgot it already. Okay, this is pretty straightforward. So now, finally, I can move on to this part. And this is the last thing that I will do today. So coercion, back to coercion just to finish it off. So I will not do this peer type resolution because it's too many things, and I don't want this live stream to last 1 more hour. So that's why I'm going to wrap it up with this thing here, which is what? Let's see. They first create a tuple here outside the domain, and then they do something with it. Let's see what they do. Okay, they create it here. They name it literally tuple with uppercase T. They have this set up as the struct that contains two U8s. Okay, then they create one instance of it here, which is a tuple, which takes this, it's anonymous tuple here as literal, which has 5 and 6 inside. So this becomes tuple. Then they cast it here into array because they specify its two-element array of U8s, and they put tuple on the right side, which is basically forcing Zig to cast it to an array. Okay, and I will just print. I will not do this. I will just print them. So what is it called? Array. And then let's do the usual thing here. And I need this to be any. And I just say array. Yeah. It did coerce. Okay, I went through this explicit cut, so I will not do these peer type resolutions today because there are too many things happening here. This will extend this stream a bit longer. So maybe tomorrow I will do it. Or let me see what can be the next thing. Result location semantics. So maybe also I will do this using namespace, comp time, assembly, atomics. Yeah, so it's very close to the end of the docs. So I basically did most of it already. So I guess I will finish these things tomorrow. I will go, sorry, these things, peer type resolution. And then I will maybe move on to result location, depending how much time I will spend on the first time. If I make it under an hour, I will do this as well and wrap it up. That's a plan for tomorrow. Is Zig based on C? Well, it is, what I read about it before is that they wrote the first versions of Zig in C. Then they use these first versions of Zig to write Zig. So it's basically like now detached from C. But they do have some types that are created in that way that it's easy to connect to C. So if you need anything from C, you can easily plug in the C code, and you can take the results of that code and use them in Zig, or the other way around. You can do something in Zig and then send it to the code that is written in C. So it's very, very nicely integrated into C. And the idea is that it works at that level where the C works, so that you have something like C, but much safer and easier to maintain. So that's the idea of Zig language. So it's a very low level language. It's not high like some other. So you don't have, for example, it's not like C++. You don't have this object-oriented part of it. So you don't have classes. You don't have all these object-oriented features of a language. You have structs. So if you're familiar with Rust, it's kind of similar in this context. So you have no objects in Rust as well either. So it's more kind of like decentralized elements. It's not centralized like in object-oriented programming, but it's more like independent parts that you can extend in an intelligent way, and very flexible and safe, what is important. Only function. So you have structs which are basically instead of objects. So it's just like you don't create a class and then instantiate objects of that class, like in object-oriented programming language, but you just like have structs which are basically something like objects in object-oriented programming. And then you instantiate those, and they can contain methods. And you also have enums and unions, which are basically, let's say, they look like structs, but they're specialized in something. So they They have a different role, but you can also have functions methods inside of them. If I only know C, C++, Java, and Python. Yeah, so this is most similar to C of these languages that you mentioned. So Java, Python, C++, they are object-oriented. C++ and C are compiled. Java is also compiled, but you don't compile to binary, you compile to bytecode. So it's something in between, I would say, interpreted languages and compiled, because it is compiled, but you don't compile to the binary code. You compile to the bytecode that is kind of interpreted, let's say. I mean, it's not interpreted, it's running a virtual machine that is a virtual computer that doesn't exist. But let's say like that. And Python is interpreted, so higher language. Yes, Zig looks like mostly like C of these languages that you mentioned. So it's that kind of level. So you have like C is here, then C++ is here, then Java is here, then Python is here. If you compare how high the language is. Okay, so that would be everything I wanted to do today, day 17. So I mentioned what I'm going to do tomorrow. So I will try to do these 2 topics that I mentioned tomorrow. And that's the plan for tomorrow. Thank you guys for being here today, and see you tomorrow. Have a nice one. Bye-bye.